An engineer named Park, who worked for over 2 decades in Hyundai's fuel injection systems development department, noticed an alarming pattern. While Korean engines were designed to be the most efficient in the world, the variable quality of global fuel and urban driving habits were killing direct injection injectors far before their expected lifespan. One night, while observing an entire fleet of taxis in Seoul experiencing idling problems and exorbitant fuel consumption, Park decided that the traditional replace and discard approach was an insult to engineering. He locked himself in his personal laboratory and, using the same precision principles employed in manufacturing semiconductors in his country, developed a low-cost cleaning protocol that didn't require disassembling a single screw. This protocol trickled down among mechanics guilds in Daegu and Busan, becoming what we now know as the Korean method. The Korean reverse chemistry concept. In the Western world, we're accustomed to the idea that cleaning something requires scrubbing or using solvents that simply wash away the dirt. However, the Korean method introduces a revolutionary concept: reverse chemistry. Korean engineers discovered that the carbon that builds up on the tip of an injector isn't just dirt, but a molecular structure that has been welded to the metal due to pressures of up to 2,000 pounds per square inch. Reverse chemistry doesn't aim to wash away the carbon, but rather to destabilize its ionic bond with the injector surface. Instead of using harsh solvents that can damage rubber seals, Koreans use compounds that trick the carbon molecules into becoming hydrophilic, allowing the constant flow of gasoline to dissolve them from the inside out. Imagine that instead of trying to chip away at a rock with a chisel, you could turn that rock into sugar so that water would wash it away. That's exactly what this method does. This approach is crucial because modern gas-injected direct (GDI) injectors operate inside the combustion chamber, exposed to temperatures exceeding 600 degrees Celsius. A conventional cleaner evaporates before it can do its job, but Korean reverse chemistry utilizes oily carriers that withstand extreme heat. The cool night fill-up trick. This is one of those fleet driver secrets in Korea that seems like superstition until you see the scientific data. The Korean method maintains that injector cleaning begins in the fuel tank, but not just with what you put in it, but with when you put it in. Fuel density changes drastically with temperature, and this directly affects the effectiveness of any cleaning agent you choose to add. Filling the tank during the cooler hours of the night or early morning allows the fuel to be denser and the additives to mix homogeneously without premature evaporation of their volatile components. In Korea, mechanics recommend adding fuel injector cleaner just before filling up on a cold night. Why? Because the thermal shock between the fresh gasoline from the station's underground storage tanks and the cool night air creates a natural turbulent mixing effect. This process ensures the cleaner doesn't float to the surface or sink to the bottom, but rather becomes a perfect solution. Furthermore, driving at night in cooler ambient temperatures keeps the car's fuel return system cooler, preventing the cleaner from degrading before it reaches the injectors. Why Koreans never use low-octane gasoline in GDI engines? If you own a modern car with a GDI engine, you're probably making a mistake that's shortening the life of your injectors every time you choose the cheapest option at the gas station. In Korea, using low-octane gasoline in direct injection engines is seen almost as sabotage. The reason isn't just performance, but thermal cleaning. A GDI engine compresses air to extremely high levels, and low-octane gasoline tends to detonate prematurely, creating what mechanics call pre-ignition. These small, uncontrolled explosions not only damage the pistons, but also create a backlog of carbonized gases that travel back toward the injector tip. In Korea, the protocol dictates always using the highest octane fuel available if the goal is to keep the system clean. High-octane gasoline allows the car's computer to advance the ignition timing, resulting in more complete combustion and sweeping carbon deposits out of the combustion chamber. It's a virtuous cycle. High octane keeps the combustion chamber clean, and a clean chamber allows the injector to work without external obstructions. The secret of the synthetic polymer stabilizer. Modern gasoline is a complex mixture of chemicals that begin to break down the moment they leave the refinery. The Korean method places an obsessive emphasis on fuel stability. When gasoline sits in the fuel rail of an unlit car, the engine's residual heat acts like an oven, cooking the fuel and leaving a sticky varnish layer. This varnish is the glue that traps carbon and clogs the injectors. The Korean secret lies in the use of synthetic polymer stabilizers. Unlike common stabilizers that only prevent gasoline from becoming old, these Korean polymers coat the metal walls of the fuel system with a microscopic, low-friction layer. It's like putting Teflon on the inside of your injectors. This prevents varnish from adhering, allowing any residue to be washed away by the normal fuel flow the next time you start your car. This trick is especially vital for hybrid vehicles, which are extremely popular in Korea, where the combustion engine is constantly being turned off and on. During these periods of inactivity, the hot fuel is a ticking time bomb for the injectors. The heat cycle method for removing varnish. Heat is usually the enemy, but in the Korean method, controlled heat is a surgical tool. Mechanics in Korea use a technique called heat cycle to clean injectors without disassembling them. The principle is simple. Different materials expand and contract at different rates. The injector steel and the carbon deposits have different thermal coefficients. The method involves bringing the engine up to its full operating temperature by driving briskly for 20 minutes, then turning off the engine and letting it sit for exactly 15 minutes. During this rest period, the heat from the engine block is transferred to the fuel rail, a process called heat soak. With the fuel stationary and hot, the cleaning additives you added to the tank have a chance to work together to break down the deposits. Then, you restart the engine and perform several hard accelerations. The strategic use of purified kerosene-based additives. If you read the label of many inexpensive fuel injector cleaners, you'll see ingredients that seem to have come from an industrial solvent laboratory. However, the Korean method rescues an ingredient that most have forgotten: purified aircraft-grade kerosene. Kerosene has a unique property. It's an extremely powerful solvent, but at the same time, an excellent lubricant. Unlike alcohol, which dries and corrodes, purified kerosene penetrates even the toughest carbon deposits and softens them without attacking the rubber or plastic components of the fuel system. In Korea, a specific blend of purified kerosene with state-of-the-art detergent agents is used. The kerosene acts as the Trojan horse that carries the detergents deep into the carbon crevices. Furthermore, kerosene has a higher flash point than gasoline, which means it helps to slow down and control combustion during the cleaning process, allowing residue to burn more efficiently without leaving ash. How the Nano cellulose fuel filter prevents injector fouling. In the Korean maintenance philosophy, prevention is key. An injector only gets dirty if it receives dirt or if the fuel degrades. The Korean method incorporates the use of nano cellulose fuel filters. While a conventional filter traps particles up to 10 microns, the nanocellulose filters used in the Korean automotive industry can stop contaminants as small as 2 microns. This is crucial because GDI injectors have such tight tolerances that a particle invisible to the naked eye can partially clog a spray nozzle, disrupting the entire combustion pattern. An injector with altered flow begins to accumulate carbon much faster due to the incomplete combustion it creates. It's a vicious cycle that the nanocellulose filter breaks at its source. Changing the fuel filter according to the strict Korean schedule, which is often much more frequent than recommended in the West, is the secret to keeping injectors clean for years. In Seoul, mechanics say, an old filter is a dead injector waiting to happen. The Korean myth of water in the tank and how to actually remove it. Water is the silent enemy of high-pressure injection systems. In Korea, a country surrounded by sea and with high relative humidity, condensation in fuel tanks is a constant problem. Not only does water not burn, but it causes instant corrosion on injector needles and destroys the cleaning ability of additives. Many cleaning products promise to remove water with alcohol, but the Korean method rejects this idea. Alcohol mixes with water and creates a solution that is still corrosive. The Korean trick is the use of demulsifying agents. Instead of trying to force water into the gasoline so it can pass through the engine, where it will cause vapor damage, these agents force the water to separate completely and be trapped by the fuel separator, or, in extreme cases, drained through a controlled tank drain. Keeping the tank above half full is another Korean golden rule for minimizing the airspace where condensation forms. An injector that processes water, even in microscopic amounts, will develop an oxide layer that provides a base for carbon to adhere with incredible strength. The preventative purge technique. Before an oil change. This is a vital tip. Did you know that the dirt in your injectors ends up contaminating your new oil if you're not careful? The Korean method synchronizes intensive injector cleaning with the engine oil change. The purge technique involves using a high concentration of fuel system cleaner in the last quarter of the tank before taking the car to the shop. The logic is brilliant. During a deep cleaning process, some of the solvents and dissolved carbon residue can seep through the piston rings and end up in the oil pan, diluting the oil. If you clean your injectors right after adding new oil, you'll be degrading your fresh lubricant immediately. The Koreans perform the aggressive cleaning at the end of the old oil's lifespan. This way, all the contaminants loosened during the cleaning phase are removed when the mechanic drains the old oil. It's a comprehensive system that protects both the fuel system and engine lubrication. The impact of carbon deposits on ultrasonic atomization. A modern injector doesn't just spit gasoline. It atomizes it using pulses comparable to ultrasonic technology. The fuel exits at such high speeds that it fragments into millions of micro droplets. The Korean method focuses particularly on how even a 1-micron thick layer of carbon can ruin this process. When carbon accumulates on the edge of the injector orifice, it creates turbulence. Instead of a uniform mist, the fuel exits in irregular jets. This causes the fuel to hit the cylinder walls or piston head in a liquid state, a phenomenon known as cylinder flushing, which removes the protective oil film and causes premature engine wear. In Korea, injector cleaning is considered successful only when perfect atomization is restored. It's not about the car starting, but about the fuel turning into a gas almost instantly upon exiting the injector. Use of nitrogen detergents. The invisible barrier. Nitrogen is a key component in modern, high-end detergency, and in Korea it's standard at most premium gas stations. However, the Korean method adds an extra layer using concentrated nitrogen amine additives. These detergents have a higher chemical affinity for the metal of the injectors than carbon itself. As they circulate through the system, the nitrogen molecules adhere to the clean surface of the injector, creating an invisible, low-surface energy barrier. It's like putting a coat of wax on a car to prevent mud from sticking. This barrier prevents carbon precursors, the heavy molecules in gasoline, from bonding to the metal. It's an active defense strategy. While solvents attack existing carbon, nitrogen prevents new carbon from forming. In Seoul, expert mechanics recommend a nitrogen shock treatment every 5,000 kilometers to keep this barrier intact. If you wait too long, the barrier breaks down and carbon begins to colonize the metal again. But for the nitrogen to reach every corner, the pressure must be constant, a topic we will see in number 8. The fuel rail positive pressure trick. Most dirty injector problems begin when fuel rail pressure drops. In Korean systems, a strong emphasis is placed on maintaining constant positive pressure, even when the engine is off. The Korean trick for effective cleaning involves checking the fuel pump's check valve. If the pressure drops when the car is parked, the fuel in the rail can begin to boil due to engine heat, accelerating varnish buildup inside the injector. Maintaining high pressure prevents the fuel from changing from a liquid to a gaseous state inside the injector, keeping the cleaning additives in direct contact with the internal surfaces. Many mechanics in Korea install temporary pressure gauges to ensure that, during the additive cleaning process, the pump is delivering 100% of its capacity. Weak pressure means weak cleaning, as the flow lacks the necessary force to dislodge the softened deposits. This attention to the system's hydraulics is what allows the Korean method to salvage injectors that others would consider lost. But before blaming the injector, we must look at the low-pressure pump, as we'll see in point 7. Why Koreans check their low-pressure pump? Every 10,000 kilometers. In direct injection systems, there are 2 pumps, a low-pressure pump in the tank and a high-pressure pump in the engine. The Korean method teaches that a worn-out low-pressure pump is the root cause of most clogged injectors. If the tank pump isn't delivering enough fuel, the high-pressure pump suffers from cavitation, creating micro-bubbles of air. These air bubbles drastically raise the fuel temperature just before it enters the injector, cooking any impurities and instantly turning them into solid carbon. Koreans perform low-pressure pump flow tests every 10,000 kilometers as part of their preventative maintenance protocol. It's much cheaper to maintain an efficient pump than to clean a set of GDI injectors ruined by the heat of cavitation. This systematic approach is what allows Korean cars to maintain their horsepower for decades. They don't see the injector as an isolated part, but as the tip of a lance that depends on the entire system to be effective. And to coordinate this whole system, the car's computer uses a secret tool that we'll explore in section 6. NOC sensors. The Korean hydrogen cleaning technique at home. In recent years, hydrogen cleaning has become popular worldwide, but the Koreans were the pioneers in adapting this industrial-scale technology for preventative home use. Hydrogen has a magical property in combustion. It increases the flame speed and raises the combustion temperature enough for the carbon to undergo sublimation, going from solid to gas without leaving any residue. The Korean technique involves introducing a controlled amount of hydrogen gas through the air intake while the engine is idling. As the hydrogen enters the combustion chamber, it acts as a chemical accelerator. The carbon accumulated at the injector tip, which is usually the hottest point, begins to react with the excess hydrogen, breaking down its long chains of heavy hydrocarbons and converting them into carbon dioxide and water vapor. What makes the Korean method special is the combination of hydrogen with a variable revolution cycle. They don't leave the engine stationary, they make it breathe the hydrogen in bursts. This ensures that the cleaning is not only in the combustion chamber, but that the generated heat also cleans the exposed face of the injector. It's a controlled pyrolysis process. Many users in Korea install small, homemade HHO generators just to perform this cleaning once a month for 30 minutes. The result is an engine that regains its original compression and injectors that shine like mirrors on the inside. The real science behind hydrogen in the Korean method lies in the creation of hydroxyl-free radicals during combustion. When the HHO gas enters the combustion chamber, it not only acts as an additional fuel, but also as a gaseous cleaning agent. Unlike liquids that must touch the surface to clean, hydrogen penetrates the microscopic pores of the metal, where carbon has become deeply embedded. The use of Ester solvents for piezoelectric injectors. Piezoelectric injectors are the crown jewels of modern engineering. They can open and close up to 5 times in a single combustion cycle. But this speed comes with extreme fragility. You can't use harsh cleaners on them because their internal piezoelectric crystals and microneedle valves can be damaged by chemical cavitation. The Korean method solves this by using synthetic esters. Esters are organic compounds that have a natural polarity. Simply put, they act like chemical magnets that seek out dirt. Unlike traditional hydrocarbon solvents that simply try to burn the dirt, esters penetrate beneath layers of lacquer and varnish, lifting them off the metal without the need for excessive friction or heat. In Korea, a blend of polyol esters is used, which are extremely stable and provide superior lubrication. This is vital because a piezoelectric injector that gets dried out by an alcohol-based cleaner will fail within a few kilometers. The ester cleans and lubricates simultaneously, ensuring that the needle's movement is smooth and precise down to the microsecond. Korean drivers of luxury cars use this type of solvent preventively every 15,000 kilometers, mixing it directly into the tank when it's 1/3 full to maximize concentration. The secret of the return valve and the bidirectional cleaning flow. Most people think that fuel only travels in one direction, from the tank to the engine. But the secret of high-performance workshops in Korea is harnessing the return flow. Many Korean injection systems are designed with a return rail that returns unused fuel to the tank. Skilled mechanics use this circuit to create an infinite cleaning loop. By connecting an external cleaning machine directly to the fuel rail, while keeping the return line open, the cleaning solvent doesn't just pass through the injector once, but circulates constantly throughout the entire system, including the pressure regulator and return lines. This constant flow creates a bidirectional cleaning action. The turbulence generated by the returning fuel helps dislodge particles trapped in the injector's internal microfilters, which are impossible to clean with a unidirectional flow method. It's like cleaning a pipe by having water flow in both directions. In Seoul, this procedure is known as fuel system dialysis. For 1 hour, the car doesn't consume gasoline, but rather a pure cleaning solution circulating at high pressure. The best-kept secret of Daegu workshops. We've reached the end of the road, the secret whispered by Korean engineers and protected by Daegu workshops like a national treasure. This isn't a product, nor an expensive machine. It's a 3-step protocol that combines fluid physics with electronic management to perform what's called a harmonic resonance cleanup. The ultimate method consists of the following. First, the system is saturated with a concentrated mixture of PEA, polytheramine, and esters. Second, the engine is induced into a controlled limp mode by selectively disconnecting an airflow sensor, forcing the computer to open the injectors to their maximum pulse width to compensate. And third, here's the magic. An external sound frequency is applied through a transducer placed on the fuel rail while the engine is in this saturated state. Sonic vibration, coordinated with the maximum opening of the injectors and the Ester chemistry, creates an ultrasonic cavitation effect within the fuel flow. This breaks down carbon not through friction, but through molecular vibration. We've broken down the Korean method in its entirety, from the secrets of the tank to the sonic resonance of Daegu. What you've learned today isn't just automotive maintenance. It's a lesson in respect for engineering. A clean injector is the heart of a healthy engine, and a healthy engine is the guarantee that your investment and your safety are protected. Implementing these techniques may seem overwhelming at first, but if you start with the basic steps and maintain discipline, you'll save thousands of dollars in repairs, burnt-out catalytic converters, and ruined oxygen sensors. The cost of a good Ester additive or dedicating time to a heat cycle is negligible compared to a dealership bill for a new set of GDI injectors.